So today we're jumping right into right triangle trig. First thing I want you to do is check your calculator, especially if you use the Wabbit. You need to make sure you always check to see if your calculator is in degree mode. To do that, remember you go to mode and then scroll down and then right here, mode. So if it's not selected on mode, hit enter on that and you'll want that in degrees because we calculate things in degrees regarding angles in this class for trig. Okay, so from here, we are going to jump right in, and you can see some of those answers there. But from the warm-up, you're just asked to see if you remember how to name the sides of a triangle in relation to an angle, and then the three trig functions. So you'll see that first triangle in reference, right? So we call this in reference to angle A, right? So we're referencing this angle. The side opposite of that angle is CB, right? The adjacent side, you can think of it as it's the one of the sides that creates the reference angle. It's the side that is not the hypotenuse, right? So the hypotenuse is always the side opposite the right angle. In the second triangle, those sides switch around a little bit when we change the reference angle. The hypotenuse does not, but the opposite side does and the adjacent side does in reference to angle C. Now we're going to use the first triangle to write down the three trig ratios that we want to be familiar with, and that is sine, cosine, and tangent. So if you remember, sine is opposite over hypotenuse, right? Opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And those three trig functions are just simply the ratio of the sides compared to the angle. That's what this function gives us, right? The ratio of the sides comparing it to the reference angle. So let's jump right in here. Anything that we do in this handout is something you want to go back and finish up as homework. And notice these are from the textbook, chapter 15. We're in section A currently. Check your answers for the ones we don't do, right? So for part A, we're going to name the hypotenuse. So part A, the hypotenuse is the side opposite the right angle. So that would be BC or CB, however you want to say that. Okay? So the hypotenuse, the side opposite of alpha. So the side opposite of alpha is AC. And the side adjacent to alpha is the side that also helps create that angle, but it's not the hypotenuse, right? So this side right here, that is your adjacent. So that would be AB. Okay, so you can finish up those other two triangles there as just extra practice. We're going to now look at, again, those three trig functions. Setting up those three trig ratios is something that we have to be able to do, right? So it all depends on the reference angle. In this case, we're referencing angle theta. So we just want to make sure we're clear as to what angle we're referencing in each of these diagrams. So for part A1, we want to say the sine. So remember, sine is opposite over hypotenuse. So opposite in this case is Q, right? So opposite over hypotenuse, R. Right? So sine of theta is equal to Q over R. For part 2, cosine. So cosine of theta is the adjacent over hypotenuse. So the adjacent in this case is P, and the hypotenuse is still R. And then tangent. So tangent of that same reference angle, theta, is opposite over adjacent, which is Q over P. So those are the three trig functions we need to be comfortable setting up because we will be using those to solve for missing pieces in a right triangle. Okay, so notice these are all right triangles. We are working on right triangle trig. Okay, so with these being right triangles, sometimes we can use Pythagorean theorem to find missing pieces, but we also need to make sure we can set up and use trig functions. Okay? So for each of these, we are going to write down the ratio. And again, if you notice, some of these have numbers, not just letters anymore. So when we have all numbers, we can actually write down the complete ratio, right? So for part D1, so sine of theta, we're referencing, notice, theta for these first three parts. So sine of theta, remember, is opposite over hypotenuse, so 8 over 17. Cosine of theta is adjacent, so that would be the adjacent is 15, 15 over 17, hypotenuse. And then tangent. Tangent would be opposite over adjacent, so 8 over 15. So now for the second set of three questions, we are now referencing the other angle, right? So same functions, sine, cosine, and it's not theta anymore, so let me make that better, and tangent. And now all of a sudden these sides switch around. So in reference to this angle, this is now the opposite. This is now the adjacent. This is still the hypotenuse. So sine is opposite, so 15 over 17. Cosine is the adjacent, right? So 8 over the hypotenuse, so 8 over 17. And tangent is opposite over adjacent, 15 over 8. Okay, so you can finish up those other two there. Notice these other two examples, they're missing a side, right? But the good news is these are right triangles. So you can use Pythagorean theorem to solve for those missing sides first, so then you can use those to help you write your trig functions. Right? So in this case, if we don't know this side, x squared plus 4 squared equals 7 squared. Solve that for x, and then use that to write your trig functions, as we did for part D. Okay. In this last question for this video, we want to find to three significant figures the unknown length in the following triangles. So to do so, we need to set up and solve a trig function most likely. Notice, because we don't have two of the three sides, we have to have a trig. We have to set up a trig function, and it all comes down to which angle we're referencing. So we're referencing this angle. So that means this side that I can see is the opposite. This side, the side we're trying to solve for, would be the hypotenuse because it's opposite the right angle. So think about the trig function that relates the opposite and the hypotenuse. That is sine of whatever angle it is equal to the opposite over hypotenuse. So now let's fill in what we know. We know sine of, we actually do know the angle, we know the degree. Sine of 56 is equal to the opposite, which is 4, over x. So now I need to solve this equation. And to do so, we have to do a little algebra here. First thing I need to do is multiply both sides by x to get rid of the fraction. So now I have x times the sine of 56 equals 4. Remember, the sine of 56 is just some number. So don't let that scare you. That's just some number. So now I still need to actually solve for x. So now here's kind of where I'm at. I have x times sine of 56 equals 4. And I need to then divide both sides by sine of 56. So sine of 56 cancels out with sine of 56. I'm left with x equals 4 divided by sine of 56. And so now I need to put that in my calculator to solve. And let's see if we can do that in the time I have left. So I need to take 4 divided by, and then sine, right? So sine is right here, sine of 56. And we get 4.824. Okay, so 4.824 would be your answer to 3 sig figs, 4.824.